Software reliability, this is the probability of this software for providing you all the function or working in a stipulated period of time under certain conditions. Now, in order to compute it, determine it, estimate it, we need metrics. So we have certain metrics. So software can work properly, it can fail, then it can be repaired. So different categories of software products, they have different reliability requirements. For example, if you see the SRS of a different small, complex, different kind of project, this NFR or non-functional requirement will contain the reliability, and that will be in your SRS, software requirement specification. That is how much reliability is wanted, is required. So a good reliability measure should be observer independent. It shouldn't be observer dependent. So the different people can agree on what kind of reliability is there. We know that the 10% of the functionality or the instruction are executed 90% of the time of usage, and 10% you use only 90% of the code. The first matrix is rate of occurrence of failure in software reliability. So first of all, it is rate. Rate means that is per unit time. First thing is clear. Or per unit something. Occurrence of failure. That is, the failure is occurring. What is the rate of these failure occurring? So it is the number of failures appearing, happening, occurring in a unit time interval. Okay. So we try to find out here that what is the, for example, distance upon time is speed. So this is the rate of changing of distance. So rate of changing of the occurrence of failure. The number of failures divided by the unit time interval. So the number of unexpected events or the events which are not favorable to the user over a specific period of time of operation is ROCOF. So you can call it, because the number means frequency. So ROCOF is the frequency of occurrence with which unexpected events or role is likely to appear in the software usage while you are actually executing the software or using it. So when we come to the quantitative analysis, the ROCOF of 0.02, what does it mean? It means that two failure are likely to occur. Please understand, it is likely to occur in each 100 operational time units steps. So time you can define, it can be any time, but whatever time you have taken it, the two failures per 100 operational time unit step. This is the ROCOF. So all idea is to just finding out the rate of how much failure occurs. It is also called as the failure intensity metric. Failure intensity metric. POFOD, probability of failure on demand. Probability, that means the value will be 0 and between 0 and 1. Okay. So probability that whenever we are demanding certain service, whenever we are demanding, requiring, expecting certain function from the software is failing to provide it. So the probability of failure when we are demanding, it is POFOD. So this is the probability. POFOD is the probability that the system or the software product will fail when we request a service, when a service or certain function or even its exact appearance is requested. For example, a website is there. When you want to access it, it is not available. Okay, the software product or the website is failing to give its service. So this is the probability that the system or the software product is going to fail whenever we are asking for it. So It is the number of system deficiencies, system problems, system defects given several systems input. That is, when you give certain kinds of inputs, the system failed to fulfill our request for a demand, for our request to get word. So POFOD is the probability that the system will fail when a service request is made. For example, 4 times we asked, only 1 time it provided a service. 1 by 4 is the probability, 0.25 is the probability. Okay, I'll give you one more example. If POFOD is 0.1, what does it mean? That 1 out of 10 service requests may fail, likely to fail. So 0.1, because it is the probability. So it is 1 by 10, that is for 10 events, one will be failing. So this is very important for those systems where the life is at stake. For the safety critical system, POFOD is essential. That is why we are talking about it. Mean time to failure, MTTF. First thing is, it is a mean, it is an average. So we are not talking about one time, we are talking about different time, we are adding them divided by the number of count. So this is the average or mean. Now coming to time to failure. How much time does it take for a system or a software product to fail? That is, car is going fine. How much time it will take that the tire gets punctured or your engine stops working? So this is the time for a particular product fail. So we will not do it for once. We'll try to find out these times, number of times, then we'll take an average, and that is the MTTF. So average time between 2 successive failures, and this is observed over a large number of failures, not one. So the system is working fine, it fails. Now when it fails again, first failure, second failure. Now when we see that the system is working fine, so the time system is working fine till the next time the system is working fine. Okay, so when it is working fine, it's okay, but the time from where it started working fine and time second time where it is working fine is the actual time we're talking about. Okay, so MTTF is not very much appropriate for the softwares, as it is mainly these metrics are mainly made for hardware. So you can just call it as total number of hours of operation divided by the total number of units. So hardware fails due to certain reason, due to environmental condition, due to wear and tear. There are many more inputs to its failure. Every hardware has to fail sometime. There is no immortality. So this indicates how frequently the component fails. Some component fail, your system will fail. But when the software error is detected and it is repaired, it is not always possible to see that error again. It may never reappear. Mean time to failure. Let us take an example to understand this. Total lifespan of our devices. How many devices? We have to divide that. So let us take an example. Imagine that a production line has a total of 3 devices. So the number of devices or assets are given as 3 devices, and they are of same kind. So these 3 devices, one completely failed at 5200 hours, the device number 2 at 4200 hours, and the third at 5600 hours. Okay, let us try to find out the MTTF, mean time to failure. So what is the total lifespan of the devices? Just add all these, 5200, 4200, 5600, you'll get 15,000. How many number of devices? 3. So just divide this 15,000 divided by 3, so you are going to get 500, and this 500 Please remember we are trying to find out the mean. So add them, divide by 3. This is the MTTR, 500 hours. Mean time to repair, MTTR. Mean is average. So whatever value will come, we have to take the average. We'll add them, divide by the number of counts. So time to repair. That is, if something gets into failure, how much time it will take to repair it. Okay, this is time to repair. So failure has happened. We are talking about the time to get it repaired. So here the failure has happened. So there is a repair time, and that repair time when it start behaving correctly now is the mean time to repair. So this mean means we are going to take the average of various values, not one value but different values, and add, and then we'll find out the MTTR. So MTTR is average time it takes to detect the issue. Mean time to repair is an average time. First we have to detect the issue, then we need to diagnose the problem, and then we have to repair the fault or the error or the bug, and then the system return to its functionality. So this MTTR, mean time to repair, is a maintenance matrix. Please remember, it is a maintenance metric that measures the average time, as I'm saying, not one time, but we have to try to find out various time and take the average, required to troubleshoot and repair failed equipment. So this is all about the time it needs for repairing. You can just understand like this. So MTTR is the total maintenance time divided by the total number of repairs. So this is an indication, MTTR, for any kind of organization, that how it respond to any kind of unplanned breakdown and repair them. For example, if there is an electricity problem in your house, it can be from your pole, it can be from your transformer, or it can be from, say, the hydroelectric from where it is coming. So the time to repair will be different in terms of different kind of problem, and to repair it will take different time. So as I said, once a failure occurs, what are you going to do? There will be additional time to fix the fault. So this MTTR is finally the measure. It finds out the average time it takes to fix the faults. Let us take an example to understand the MTTR. This is equal to total time spent repairing divided by the number of repairs. So just imagine that a production line has 3 devices that went down. The first one was down for 4 hours. The second was down for 2 hours. And the third for 3 hours. How to find out the MTTR? So what is the total time spent in repairing? 4 hours, 2 hours, 3 hours, add them. 9. What are the number of devices? 3. Divide 9 by 3, you are going to get the MTTR, which is 3 hours. Mean time between failure. So mean time between failure is, see, first of all, it is a mean. So you need to take the average. So once failure happened, you need to repair it. And then there will be correct behavior. And in between that, there will be some time. So one failure, and whatever time it takes to repair and correct behavior, there will be another failure. So the time between two failure is mean time between failure. I hope you got the idea. One failure, second failure. The time elapsed between these two failures is the time between failure. When we take a lot of these numbers, that is whenever it happens, we combine them, take the addition divided by the number of the, say, values we have taken, count we have taken, that will be mean time between failure. So MTBF, mean time between failure, is the predicted elapsed time between inherent failures of a mechanical or an electronic system or a computer system or a software product during normal system operation. So how can you calculate it? it can be calculated as arithmetic mean, that is the average, that is why it is called mean time between failures of a system. So 2 failures, the time between it is MTBF. This term is used for repairable systems, while mean time to failure MTTF denotes the expected time to failure for a non-repairable system. MTBF simply total working time minus the total breakdown time and divided by the number of breakdowns in this stipulated time. So just subtract this breakdown time from the total working time divided by the number of breakdowns. So this is going to be MTBF. We can combine this MTTR and MTTF, that is the mean time to repair and mean time to failure, and then you add them, that is the time of MTBF. That is mean time between failure, because something happens, some failure happens, there will be a time to get it repaired, and after that the system will work fine until it reaches the second failure point. So if you say MTBF of 100 hours, what does it mean? It means once failure has occurred, the next failure will be expected only after 100 hours of clock time. Please remember, this is not the running time. Just see your clock, that will be 100 hours. Not your system is working when. Okay, the time measurements are real time and not the execution time of the software product or the electronic device, as it was done in MTTF or mean time to failure. So this is the clock time. Just add MTTF and MTTR, you'll get MTBF. Now let us take an example to understand MTBF. This is the total uptime divided by the number of failures. And this MTBF, let us take an example. Imagine that a production line runs 130 hours in a week with 4 outages. Within whole 130 hours, there is 4 times it failed. The first one lasted for 2 hours each. That is the first two, that is 2 hours and 2 hours. First one, second one, 2 hours, 2 hours. Okay. So the first two, they were out for 2 hours or down for 2 hours. And the last two, that is the third and fourth one, they took 3 hours each. So now let us find out the MTBF. So 130 hours is the total working time from the start to end. 130 hours, it is being said that all 4 outages are there, 2 for 2 hours, 2 for 3 hours. The total number of outages time is 2 into 2, first was 4 hours, and the second is 2 into 3, that is the 6 hours. Add them, you get the 10 hours. So this is the time where the system didn't perform, it was not well. Okay, so this 10 has to be subtracted from 130, as I showed you the actual formula. So 130, you have to separate out this 10 hours. So that will be the time 120, and that this is the total uptime. And how many number of failures are there? Okay, you have to divide it by 4. So that the MTBF is 30. So this means that when the operation is live, the average time between the failures is 30 hours. Now let me go a step further. Let us try to find out the failure rate. What will be the failure rate? So as I suggested, 30 hours between 2 failures, 30 hours between 2 failures, like this. Average we have taken. Okay, we will try to find out the failure rate. You just have to take the reciprocal of MTBF or mean time between failure. Failure rate is 1 by MTBF. 1 by 30 is 0.033.